Hi, everyone. Welcome to today's webinar, Solar Power Plant Automation with Zenon. Thank you for taking your time and joining us today. We have some very interesting topics ahead. Let's see today's speakers. We have a special guest speaker today with us, Darjon Dhamo, SCADA system engineer from Euroelektra. Our next speaker will be Dejan Sršen, zenon sales engineer from EXOR ETI Slovenia, and Dalibor Bobic, zenon sales engineer from EXOR ETI Belgrade. My name is Anka Udovč, and I'm head of marketing in EXOR ETI, and I will be hosting the webinar. Let's see what's on the agenda today. First, we will talk about EXOR ETI and COPA-DATA Company profiles. We will continue with monitoring and control of solar power generation, and we will show demo projects in commercial and industrial scale. Later on, we will talk about references, and our guest speaker, Darjon Dhamo from Euroelektra, will present supervising, control, and energy forecasting of a PV system. At the end, there will be time for Q&A session. So please send all of your questions that you might have to the Q&A box or to the chat box, and we will answer them during the webinar or at the end of the webinar. The webinar is also being recorded, and you will receive the recording in the following days to your email address. And one last thing, when the webinar will finish, a survey will pop out in your browser, so please be as kind as to fill it out. We would like to hear your feedback. Okay, so let's start. I would like to invite our first speaker, Dalibor Bobic, who will talk about EXOR ETI and COPA-DATA Company profiles and monitoring and control of a solar power generation. Welcome, Dalibor.
Thank you, Anka, for this introduction. More welcome from my side too, and let's jump into company profiles, starting with EXOR ETI. So we are representatives of 10 different well-known companies worldwide, and we are located in Balkan region, covering 8 countries, with our 3 offices in Slovenia, Croatia, and Serbia. We have more than 500 customers, and we bring to our customers innovative software and hardware solutions. Speaking about COPA-DATA, the manufacturer of zenon software for industrial and energy automation, we can say that they are existing for more than 35 years now, dealing just with software development, and together with us, we are doing together software sales, technical support, and professional services, and all kinds of trainings and certifications for zenon. We have together more than 5,000 successful customers and more than 200,000 installed zenon systems worldwide. Speaking about zenon, what we will cover today is these main functionalities and features, starting with scalability, covering flexibility and openness, and interdisciplinary nature about zenon. Let's move on to monitoring and control of solar power generation. When we speak about zenon, we can speak about Zenon Energy Edition, especially today, covering all different kinds of features from control and awareness and connectivity, compatibility, scalability of different projects. We can cover multiple application profiles, starting with renewables, which is our today's main topic, of course, substation automation, distribution, and hydropower plant with different kind of applications. From renewables side, we can cover wind power, solar PV, which is our main topic today, battery energy storage systems, and hydropower plants, small or big one. This is landscape what we can cover with zenon, so we can see the many different sizes from industrial and commercial part, from distribution level, transmission level, onshore and offshore applications. So we need to focus today on solar systems, so we can find them in almost all parts, so small and big one. But let's do some statistics. I found these chart diagrams, which shows how important is this topic today and how big are projects done last year, let's say, especially with this exponential growth during the last several years, just for solar PV installations, and also the segmentation of PV installations like a rooftop and utility scale. Also interesting when we speak about renewable energy, more than 50% of electricity production was done with solar PV installations. With solar PV, we have so many advantages and disadvantages, which is really different from other renewables, but we will cover today what are the main features of Zenon and how to improve these systems in so many ways. Some of the main advantages of using Zenon is, of course, comprehensive monitoring and control, which is really important when you have this size of power plants. Of course, advanced data analysis, we need to collect all data, we can do advanced analytics, and of course, enhanced visualization reporting is continuation of this part. Regarding maintenance, fault detection and diagnostics are really important things which where you can react really fast and have all the information real time. Scalability and integration, this will be a special part for today, so we can start with really small projects, small scale in terms of the size, the power, also the investment, and integration with different systems, which we will see also today. When we speak about industrial and commercial areas, it is always like power from 10 to 100 kilowatts for office buildings, several hundreds of kilowatts for factory rooftops or open space from 1 megawatt and higher. And these industries requirements are specific in comparison to utility scale, solar PV, SCADA, real SCADA systems for PV installations from several megawatts and higher, with connection to different systems like substations or battery energy storage systems. How we can do this? We can use more than 300 communication protocols in Zenon out of the box. So covering energy protocols when we speak about all sizes of solar PVs, including standard protocols like 61850 or 6870, 101, 104, and including Modbus with SunSpec Alliance within SunSpec Alliance. For the smaller projects, for industrial projects, we need to connect to make the connection to some other systems. Will it be building automation projects with some standards for building automation, or to compare the data from energy management systems or production information system with different standard industrial protocols? It can be done with so many protocols that Zenon provides out of the box. The development is, of course, really secured according to 62443 IEC standard. And when we speak about cybersecurity, it's really 100% in-house development, providing the end customer with secure system with encryption, network encryption, TSL encryption, authentication, and monitoring. Let's dive into integration of this kind of power plants. So photovoltaic can be found in different areas, starting with small power plants with low voltage, and also with solar farm with high voltages. This is kind of renewables mix, which means integration with different power plants, with wind farms or energy storages to balance the network. And it's always naturally volatile, so we need to have mechanism for demand supply balancing. And in this case, we can see this as a kind of virtual power plant. So multiple sites with solar PVs, with wind parks and battery storages to make this balance, to make the network stable, and then to connect to grid operator really safely. When we speak about different sites, we also have a possibility to integrate Zenon IoT services to connect all the different sites together in one system with all security features, of course, identity and policies, with data storage, and it can provide us with the functionality to integrate first-party and third-party applications just to make a kind of control center and to access all locations like in real time, like you're on the site, let's say. The best feature today is solar PV application set. COPA-DATA provides the system integrators and end customers with one simple solution out of the box, which makes project times really shorter. It's complete package with necessary information, components, templates to set up complete SCADA application. And when we speak about application set, you have process object libraries, project templates, strong focus on security, predefined screens, functionalities, and the possibility to integrate all parts of this kind of project, so we can make a connection to substations, the solar inverters, combiner boxes, metrology, energy counters, emitters, solar trackers. Everything can be easily integrated into this existing template ready to use for our customers. Last but not the least, I wanted to share the complete kind of web where you can find all functionalities of this solar PV application set, so you can benefit from all kinds of awareness, scalability, and different kind of things. This was from my side. So Anka, I'm giving the word back to you.
Thank you, Dalibor, for your presentation. So let's move to the next part of today's webinar. I would like to invite our next speaker, Darjon Dhamo, who will show us a demo project of commercial and industrial scale, and he will also talk about our references. Welcome, Darjon.
Hi, everybody. Thanks, Anka. Just to tell everybody, you can already ask questions if you have any in our chat box here, and we will answer them during the webinar and after the webinar. So I will be presenting references and one commercial demo project. So if we just start. Okay. So our first reference is Solar One photovoltaic plant in Jordan. So these are 4 individual solar farms with total output of 57 megawatts, and customer is Jordanian National Electric Power Company, and we use Zenon for SCADA solution as a SCADA solution for control and monitoring. We use different Zenon drivers to communicate according to these standard energy protocols. So we also use Zenon Logic, which is our soft PLC for precise calculations. Then when I will show later the demo project, that simulation will be done through our soft PLC, so Zenon Logic, which can be used for calculations, for control, power plant control, and so on. This webinar will be later also on YouTube. So if you want to know more about this specific success story, you can just write the web address written here below, so you can find out more about this specific reference. The next reference is Cam Hoa solar power plant in Vietnam. It's also a big utility scale project, 50 megawatts. Zenon is used as a human machine interface and as a gateway software, and connected to a 110 kilovolt substation and power line. And now our biggest reference is from Australia. This is Yarranlea Solar Farm, 110 megawatt megawatt peak generation plant located in Brisbane, in Queensland. These are 440,000 solar panels on 250 hectares. connected to medium and high voltage transmission networks, and it is in service since February 2020. Now our local reference from Slovenia, from Gorenjske elektrarne. This is 20 photovoltaic plants dispersed across Slovenia. Combined power of solar power plants is 3.5 megawatts. And the plants are connected to a distribution grid of different distribution system operators. We are talking about multiple PV inverters. Archiving is done with the help of Zenon Historian. We are also having solar irradiance monitoring. And here particularly, we just use SQL driver and a Siemens driver. So this is still a utility scale. And now let's look one reference from Potsdam Chamber of Crafts, which is, let's say, quote unquote, a smaller project with combined power of 144 kilowatts in solar power plants only, so from photovoltaics. So, and then we have additionally 640 kilowatt battery storage system. But these 5 references can give you an idea that Zenon can be used for the smallest projects and the biggest projects. Then at the end, it all depends on your use case, on the topology of license structure. But basically with the same software, we can use all benefits from energy standards in terms of different communication protocols, safe switching with our command processing. And then when we scale down this whole possibilities, we can just use things that we need for a smaller use case, for a smaller solar power plant on top of a roof of our commercial building, of our plant, and use Zenon as a, let's say, only for visualization purposes and less for control purposes. So I will try to share my next screen. This is it. Okay, so now we have here an example of a production in a commercial building from a rooftop of our production plant. So we have a solar power plant with peak power of 300 kilovolts. And this is the main overview. So in smaller applications, which have here basic parameters, some nice numbers in terms of saved trees, CO2 emissions, but also we can then look at the our audit trail, where we can see who has been changing the system, who has logged in, what variables have been changed. Okay, this is it from, okay. So I have some difficulties here. So I just go back. Okay, basically you have the idea of this scale over smaller solar power plant. And I will just transfer the word back to Anka and to our next presenter.
Thank you, Dan. So now we will have our special guest speaker, Darjon Dhamo from company Euroelektra, who will present supervising, control, and energy forecasting of a PV system. Hello, Darjon, and welcome.
Hello, Anka. Thank you for introducing me. So I will share my screen now. I am Darjon Dhamo, lecturer at Polytechnic University of Tirana, and also SCADA system engineer here in Euroelektra company. Today in this webinar, I will present a case study with the title Supervising Control and Energy Forecast of PV system, which is installed on the terrace of Lufra factory located in Lushnia city. Before to do that, I will do a short presentation about Euroelektra company. It is an Albanian company specialized in distribution of international brands products in the electrical and energy sector. The company operates in the renewable energy sector through PV plant, which transform potential energy into grid energy without affecting the environment. The other sectors when Euroelektra operates are in electrical products and energy efficiency. Until now, this company have installed above 40 megawatt here in Albania, and also we have project in Italy, Catania, and also we have project in Macedonia, so North Macedonia. Company projects, the most important project which is implemented by the Euroelektra company is Vaudeus. It is a PV plant installed on site of the dam, as you see here. It is 5.1 megawatt, and it saves per year this amount of trees and avoid per year this amount of dioxide carbon. Also, other projects implemented and designed by this company is TV clan, which is approximately 1 megawatt, and it saves per year this amount of tree and avoid per year this amount of dioxide carbon. Also, as mentioned before, Euroelektra company has installed in Catania a PV system with total capacity of 2.2 megawatt peak, and it saves per year this amount of trees and avoid per year this amount of dioxide carbon. Also, other project is the Centra Tectare Universe, Tirana is Gate, Coca-Cola bottling Cypria, and other project which is important, and it is the case study of this webinar. It is a PV system installed on the terrace of Lufra. It is a 1.1 megawatt peak. It saves per year this amount of trees and avoid per year this amount of dioxide carbon. Also, the company have done in Coca-Cola, Stadtkraft, and Pascucci some EV charge installations. Here are listed the company partners of Euroelektra company. Okay, I will go now to PV SCADA system for the Lufra factory. Firstly, I will go to the, so I will show you the location of Lufra factory from the map. we will see 3 different locations. Well, the first is Lufra Plastic, the second is Lufra Warehouse, and the third is Lufra Administration. After that, I will go to the IT topology. Here I will explain the communication architecture of a SCADA system. So for Lufra Plastic, there are 12 inverters which are connected with the data manager, which is the data logger. The inverters communicate with the data manager through SolarNet protocol. And also the smart meters communicate with the data manager through Modbus RTU protocol through RS485 interface. Also, in warehouse, we have 10 inverters. They are communicating with a data manager, and also there is a smart meter, which is communicating again with Modbus RTU with the data manager. And the third is administration place, when we see here 7 inverters communicate with the data manager through the same protocol, SolarNet, and the smart meter communicate with this data manager through Modbus RTU. 3 data managers are connecting with switches, and they are communicating with the router of our company here through Modbus TCP protocol, and the router is connecting with the server when the service engine, because this is the application called the service engines, run the SCADA system. So this is the communication architecture. I will go now to the overview screen. We have here some sub screens, so some sub pages. Here in the inverter status, we see 29 inverters. They are total inverters of PV plant. I will click in one of them. Let's do it from inverter 23. So here we open the inverter data. We see the AC part of the inverter, where are the AC electric quantity, for example, active power, energy, active energy, apparent power. This is reactive power, power factor, frequency, the voltage of each phase, and also the current of each phase. Also, we see the 3 graphics here about power production of the inverters, active power production, voltage, phase voltage, and also the frequency. So we can see the parameter also in DC part. We also see here we see the status of the inverter. It is in MPPT status now. The inverter is producing. Also here we can see the fault of each inverter, or the alarm of each inverter. Here the inverter is working properly and we don't have any alarms. In manual mode, I will explain what is the manual mode here. We have a page, manual and automatic mode. In manual mode, we can change the set point of the inverter. And after we change this set point, we confirm it here. Or also we can do the reset of the inverter from a distance. Here we can see also the parameters of the inverter, so it is the inverter 23, when we can change the parameter of it, and we can export because it is a write register here. This is the model of the inverter, firmware version, and the make of the inverter, which is Fronius inverter. Here we can see the alarms, the total alarms of the PV system. So these pages are same for all of the inverters. I will go now to this data, which is the smart meter data about the administration, plastic. This is the warehouse and the total. So the total power, which is imported from the grid, now is this value, and the active load is this value here. We can see the graphic of load, and also we can see the energy production and the energy forecast here in these graphics. In a string combiner box heat map, we can see the color of string combiner boxes. These colors are dynamic, so it changed the color by them power. So if the power is, if the inverter is producing too much power, above 90% is this color, and the other color are for power, which is above 19, so sorry, under 19%. Also, the color change here depends from production of the inverter. Here we can see the alarms. So we can see here the alarm page. Here we can see the information about the sun position. The input of the model are latitude, longitude, and time zone. The model is implemented in Zenon logic, which is virtual PLC, I think. There we can insert the model, we can insert the algorithm, and if we change this input, we can see the output, which is the sunrise, sunset, azimuth, and the elevation angle. This algorithm is well for the tracking systems. Also, here we can see the active power, which is producing by the PV system. We can see also the total import and export of energy. This is the daily energy, yearly, and the total energy produced by this PV system. This is the earning of production. This is daily, yearly, and total. Here we can control the inverter also through this application or through web. We will see after this application explaining. We will see also the HTML page, which are done for Lufra factory. If we need to change the set point, it is in a percentage here. If we go to 50%, all the inverters go to 50%, but I will don't do that because it have a problem of production through the inverters. Here we can see the inverter page, the status, the efficiency, the power, and the current. This is the single line diagram. Here we can see the status of each circuit breaker of the inverter. And also here we have an opportunity to see the data of the inverter, which is the fourth inverter. It takes some time in order to read all values because of the distance from SCADA or from a server to the factory. Yeah. This is the alarm page. So at this time, it is a grid error. The factory was disconnected from the grid today at this hour. Also, we can see the historic data. If we change and we go to 1000 data, we go and we see the alarm, the historical alarm. Here we can see the events, and this is the forecast. So we can see the energy production forecast for 5 days ahead in each hour. So this is the hourly forecast. We can see the energy forecast. This is the humidity, wind speed, temperature, and the weather condition. In Analyze, we can see the graphics. Here, there are 2 graphics. One is for active load of the factory. The other is for PV production of the factory. Sorry, of PV plant. These are the graphics of the production of the inverters. We can add other inverters here in order to see the production of this inverter before. These are the voltages of the inverters. So here is introduced. If we go to filter, we see the inverter 1. This is the phase A, B, and C voltage of the inverter 1 located at plastic. These are the current and frequency. Also, we can generate reports. If we go to the first report, we can, this is a report of PV production of the PV plant. And this data we can export and to create an Excel file. In order to see when the Excel file is located, we can go and see it through user, public documents, zenon project, and it is located here. This is the time and the date where the report is created. Also, we can see the report of forecast. Okay, this is all about application. I will go now to explain also the HTML pages. Okay. So this is the first page in HTML. We can log in through admin. So these are our credentials. So until now, here in the SCADA are implement only 2 PV systems, but we will do that for other systems. This is total generated power for both systems. Here is shown the energy produced by this 2 PV system, and this is the earning. If we go to our case study, we can see the data of active power generation, the load, and also we can see the active power here, which is the active power imported from the grid. Here we can see also the graphics about the power production, power of the load, and also power which is exported and imported from the grid, and also the power prediction. These are the forecast data. This is the energy forecast this humidity, wind speed, and also temperature. Inverter data, we can see the inverter data here. So if we click to inverter 10, we also, as we saw it from application, we see the data of the inverter. Again, from the web, we can turn on and turn off the inverter, or can change the set point of the inverter. We can do it manually or automatically here in this setting page. Also here we can see the data which I explained in application, except here we have other data. It is about energy produced, which is the monthly energy. It is earning of the month, and this is the total energy consumed by the factory through PV system. IT topology is the same. Alarms also, and events are the same as application. Here is the data of each hour for 5 days ahead about the forecast. And here we can see the graphics about weekly. It is the production of PV plant. It is the power, which is export to the grid. This is power, which is imported. And this is the load, power load. We can see also the other data about energy. Daily, monthly, yearly, and total energy. Okay, thank you for your attention. This is the case study of Lufra factory. So,
thank you.
Anna, you can proceed.
Thank you, Darjon, so much for this interesting use case. I'm sorry we are a little bit behind the schedule, but we have a Q&A session left. We'll try to be brief. You can still send, if you have some questions, to the Q&A box. Okay, so let's move to the first question. I'm interested in licensing of SCADA. Is it by number of tags? Does it support server-client licensing? Yeah, Dalibor, you can answer this maybe? Mm-hmm.
Yeah, as I mentioned at the beginning, scalability is really a great feature in Zenon, so it can be licensed also via tag number with different modules, with different drivers. You can choose according to the project size. Of course, with our support, we can make a really specific offer for the specific size of PV power plant. So modularity is really high and scalability is really high, so you can even upgrade to unlimited number of tags and include all modules, all communication protocols that are available. In short, yeah. Just contact us and we will make an offer for specific use cases.
Thank you. Then I believe we have some questions for Darjon. First one is, what are the benefits of the SolarNet protocol to integrate inverters? What is the reason to use the protocol in favor of other protocols?
No, it is a Florence protocol, and it's used to communicate inverters with the data manager. And this is the only protocol which the inverters communicate through data manager, which is the data logger of the PV system.
Thank you. Next question is why there is no alarm description in alarm list? How to identify what is type of alarm?
There is a description. For example, it was the number, and it is the grid error. for the alarm. That it means the grid error. It means that the factory was disconnected from the grid.
And can I sort alarm by priority?
Yes, we can do it there in filter.
Okay.
In filter option, we can do that.
Okay.
Yeah,
and
yeah, also we can change the time range of trend view.
Okay.
There is an option to do that.
Perfect. So
In
this
filter,
answered
in
my
filter,
next.
yeah.
This answered my next question. And then we have one more question. I'm not sure if it's for you or maybe Dalibor or Dan. Which protocols do you support for solar plants? Dalibor.
I can jump in. Yeah, as I mentioned, it depends on the size. So if it is utility scale or rooftop for industry, all protocols are available in Zenon, so you can use any of them depending on the use case. As I mentioned, if you need just the solar power plant, like utility scale to connect to substation, you can do just this. But if it is on a rooftop, you can use Modbus or Siemens or any other standard industrial protocols to connect to different systems, even SIP, even energy management, line management, efficiency monitoring. You can use any of these protocols that are available in Zenon. And you saw so many of these that Darjon used and in our demo projects. This is in general.
Modbus TCP is the correct one. So Modbus is for communication through solar inverters. It is the most common protocol to do the communication through SCADA and through PV inverters.
And if I can dare to test my microphone, it's okay. Just one final remark. My demo project is available also in terms of visualization solutions and functionality solutions to copy it for your project, as has been Darjon's live project. It is based on Zenon demo solar power plant project. So all solutions, these templates, demo projects, smart objects in our Zenon projects can be reused for your end customers and by system integrators.
Okay, and then let's, two short questions more.
Okay.
Yeah, I think it's for you, Darren.
Yeah, I can respond again about the reports. Yeah, we can export the consumption report. We can click to create Excel file, and then we can open it, the Excel file. We can do it manually or automatically if we want. So we can do the reports automatically for each day if we want. For each day or for monthly, yearly, it depends if we need.
Okay, thank you. Did you ever connect to PPC power plant controller? I think this question is also for you, Darjon, if I'm not wrong.
No, we have taken the data directly from the data manager.
Okay. Okay, I think we have come to the end. We ran out of time also. If you have any more questions, you can always contact us to these email addresses that you can see for Slovenia, Serbia, and Croatia. The webinar is being recorded, as I mentioned before, and we will send you the recording to your email address. I would also like to invite you to visit our YouTube channel. It's called EXOR ETI Group, where you can find all our past webinars from different fields and brands and other interesting videos. Please fill out the survey that will pop out in your browser at the end of the webinar. And thank you again for joining us today. And big thanks to all of our speakers to joining us and taking the time. I hope you all enjoyed the webinar and see you at our next event. Have a nice day.